At this point, perhaps a little general information is in order to give you an idea as to the scope of the installation. You see, when you are to install the mini-link, you will not need to plan or calculate anything, since there are link planners and engineers whose job it is to do this. The planners will decide the antenna heights, the headings and the hardware configurations for you to install. But with a little information, you can have a better understanding of just what you are doing. Well, as you already know, the radio signals follow a line of sight path. In reality, this is not strictly true, because radio waves are bent when they pass through a changing atmospheric density. At long and medium waves, up to about 10 megahertz, signals will be totally reflected back to the Earth. But at microwaves, they're just bent a little bit towards the Earth. This means that a radio signal can in reality travel just a little bit over the horizon. If you have a free space path between the transmitter and the receiver antennas, then obstacles placed between them obstructing the line of sight path will cause signal loss or attenuation. As the microwave frequency rises, so the wavelength shortens, which means that rain and snow particles also become significant. If you were to experiment by placing objects between the sender and receiver and watch how they influence the signal strength, you will see that the signal path has a thickness, a very real thickness. It is shaped like a cigar, and the thickness in the middle depends upon both distance and frequency. Now, this cigar-shaped area is known as the first Fresnel Zone and is considerably narrower than the antenna beam width. When you install the mini-link, you must always take a look at the signal path between the antennas, just in case there is a new or a temporary obstruction that was not included in the planning. New obstructions could include anything really. Fairground structures, building site cranes, scaffolding, newly erected buildings. Even trees can grow to become an obstruction. The equipment you need to install may vary quite considerably, depending upon the configuration. A simple point-to-point radio link is often called a hop. And a single hop feeding one radio base station, for example, would be designated 1+0. You may hear the term unprotected hop, which is another way of saying that there is no spare link. If the link stops, then so does all traffic. Now, a protected hop is where you may have to install several mini-link antennas to provide a duplicated hop, a duplicated transmission network, or hot standby. For example, the 1+1 configuration. If one link fails, then the standby link will continue to provide service, resulting in more reliable service to the end user. Another alternative to the hot standby is diversity. This is where two or more links are working together to send duplicated information, but by different paths. The most common is space diversity, where the two links have several meters of vertical or horizontal space between the duplicated antennas. Either of the two radio links provide 100% traffic. But if the signal strength should fade due to rain, multiple signal path reflections, or even passing obstructions, then the two links may still fade, but not at the same time. Another form of diversity is frequency diversity. Multiple signal path fading is also frequency dependent. So if two radio links have different frequencies but the same antenna, then the fading of both channels will not occur at the same time. If the frequencies are very different, then only one channel may be affected. If some form of diversity is used, then you will be installing more than one radio unit on the tower. There will typically be at least two of everything: radio units, maybe even antennas, cables, the lot.